Representation of RL, RC and RLC circuits. So in this first one is RL circuits. So again taking RL series circuit, so resistor and inductor connected in series, and representing resistor as R and inductor with the impedance offered by the inductor, that is JXL. So they are connected in series, and this combination is connected to a voltage source V, and I is the current coming from the source and entering into RL series circuit. So VR is the voltage across the resistor, and JVL is the voltage across the inductor, and V is the source voltage, three elements and one current. So same current is flowing in the source, resistor and the inductor. So here if you apply KVL for this loop, V equal to VR plus VL, and V is equals to VR plus JVL. So VR bar is VR and VL bar is JVL. So again VR equal to R into I and VL equal to XL into I. So V equal to Ri plus J XLI. So taking I as common, V equal to I R plus J XL. So here Ri is VR plus J VL. So V equal to VR plus J VL. So phasor diagram, writing phasor diagram. So to understand the phasor diagram, I am taking some numbers to the currents XL and R. Let I equal to 2 amperes, so that is 2 plus J0 in rectangular coordinates and 2 at an angle of 0 degrees amperes in polar coordinates. XL equal to 10 ohms, R equal to 5 ohms. So the resistance offered by the resistor is 5 ohms and the reactance offered by the inductor is 10 ohms. So V is equals to R into I is 10 and XL into I is, that is 10 into 2 is 20. So V equal to 10 plus J 20. So that is in polar coordinates it comes as 22.36 at an angle of 63.43 degrees. So VR is 10 volts, so 10 plus J0, 10 at an angle of 0 degrees. If you take VR alone, it is 10 at an angle of 0, and if you take VL alone, it is J20 volts, that is 0 plus J20 and 20 at an angle of 90 degrees. So if you draw the phasor diagram, so phasor diagram is nothing but representing currents and voltages in the circuit. So here there is one current and three voltages. So representing all the currents and voltages in a planar diagram, it is said to be phasor diagram. So it is a vector diagram. So here it is a reference, positive real axis is a reference, and current, if you see the current, it is 2 at an angle of 0 degrees. So it is making an angle, current is making an angle 0 with the reference, and on the reference it has 2 units. So I equal to, so from here to here it is I equal to 2 at an angle of 0 degrees. And if you see the voltage across the resistor, VR equal to 10 at an angle of 0 degrees. So it is also, VR is also making an angle 0 with reference, means VR is in the direction of the current. So but length is 10. So from origin up to here it is 10. So 10 at an angle of 0 degrees. If we see the voltage across the inductor, it is 20 at an angle of 90 degrees. Means with the reference it is making, VL is making an angle 90. So this is 0 and 90 means a anti-clockwise direction 90 degrees. So it is in the positive imaginary axis direction and the length is 20 units. And the resultant is V. V is 22.36 at an angle of 63.43 degrees. So means resultant is making, that is supply voltage is making an angle 63.43 with reference. So with reference this is making an angle, reference is making an angle, so 0, that is 63.43. So here VR, so VR and is in the direction of the current, is in the direction of the current, and VL is head of the current by an angle 90 degrees, and the resultant voltage, that is supply voltage, is ahead of the current by an angle 63.43 degrees, and magnitude of the resultant voltage is 22.36 volts, and magnitude of the voltage across the resistor is 10 volts, and magnitude of the voltage across the inductor is 20 volts. So phase angle here, the angle between supply voltage and the current coming from the supply. So the angle between supply voltage and current coming from the supply is 63.43 degrees. 63.43 degrees. So power factor. So power factor equal to cosine of the angle between voltage and current. So here the supply voltage and the current coming from the supply. So that is cos 63.43 becomes the power factor, which is 0.447 lagging. So lagging because current is in the direction of the reference and supply voltage is ahead of the current. So current is lagging the voltage. So that's why it is lagging. So 0.447 lagging. So is the power factor. So impedance. So what is the impedance offered by the circuit, RL circuit? So impedance is equals to voltage to current ratio. So voltage to current ratio. So from equation 3. So here this is the equation 3. So taking I to the left hand side of the equation, you get voltage to current ratio, which is equals to R plus J XL. So that is the impedance offered by the RL circuit connected in series. So Z equal to voltage to current ratio, which is equals to R plus J XL ohms. So here in this case, so Z equal to R plus J XL ohms. So in this case, in this example, so where I equal to 2 amperes, XL equal to 10 ohms and R equal to 5 ohms. So impedance offered by the circuit equal to Z equal to 5 plus J 10 ohms. So this is about representation of RL circuit. Representation of RL circuit. So in next video, so I take up the representation of RC circuit.